This is the demonstration for a humanoid type A called BIOLOID. It has an AX-S20 inside its head here. And we'll be using two programs. First, the BIOLOID to AX-S20 bound.tsk. It also uses the BIOLOID to like.mtn file. So let's explore first what the code is going to do before we do a demonstration. So at first, the start program, go to motion page 1, which is init here. So basically just stand up straight. And then play motion 129, which is way down here. And 129, just make it crouch a little bit lower, make it a little bit more stable. And then we initialize the two parameter, FB balance in it, and basic forward and backward balance in it, and then right and left balance in it. And then we'll collect the data. So the AX-S20 inside here is a dynamic cell compliance sensor. So the address is 105. So at 105, we got the one that is forward backward balance. Right left balance is address 40. Forward and backward balance address 38. Basically, just collect 10 data point, then divide by 10, take the average, and set that as FB balance center and RL balance center. So these are the goal for the robot to maintain for the rest of the program. And then if I play a little music to let the user know that it's ready to be play with, essentially. And then it goes to motion index 128. So you can see here balance 28 is essentially the same thing as 129, except it just keep on calling itself here. You can see that the next page is 128, 128 called 128. So it go in and try to maintain that balance at all times. And then in order to keep it going, we got an endless loop here. Normally, when I test it, I have it printing out some output on the screen. But in practice, that will slow down because and then also I have to hook it up through the USB cable to print the data. So usually I don't need that for demonstration. So I comment that out. So basically in the main program, I essentially just endless loop to keep on trying to maintain this page 128 here and keep it going. That's all. The real work is done by the callback function. It's executed every 8 milliseconds after 7.80. You want to be that precise. So essentially, when it is false, it's not the initialization, it will go in and trigger all this. Okay, so the initial value center here, you pick up some new data, it calculates the error, it ignore all the small error, but you divide by 16 first, and then start integrating all the error, basically add them up. If it's bigger than 248, it's clamp it to 2048. If it's less than minus 2048, it clamp it to minus 2048. Once you pick it up, we just pick them up like that here. It just goes through every time it goes through the bound, the callback. We add those two. And then it scale the error differently and then figure out the final value 0, 1, and 2, 0, 1, and 2, because eventually this will apply to different locations, different joint of the robot. So they have different values. So more detail I explained in the book, explaining each of these settings. For this one, I just want to show you the general program and what it does. So let's get the video going. So this is the bot here, and we're ready to do. Power on play mode, and let's play it. I'm gonna go up. So that's page 1. and then it's doing page 129. So when I play the music like this, it's ready to go. So it's not very fast, but you can see it can do it sideways. Okay, so I'm going to lean it forward too. You can see it can execute pretty much at a compound angle if you need to. So if you see if you're shaking too fast, it may get into vibration, then it may be unstable. Not too bad here. So I'm doing it at a compound angle and then jiggling it a little bit, but it's still. Woo! Here we go. Coming back again.